The next big enterprise AI risk may not look like a cyber attack. It may not look like a model hallucination. It may not even look like a failure. It may look like productivity. Picture a global manufacturer planning the next quarter. It makes industrial components used in energy systems, transportation equipment, and commercial facilities. It has plants in North America and Europe, sources materials from Asia, works with logistics partners across regions, and sells into markets where tariffs, sanctions, energy prices, and regulations can change the economics of a deal quickly. For years, the operating model was messy but familiar. Supply chain watched suppliers. Finance watched costs. Legal watched sanctions and export restrictions. Operations watched plant capacity. Procurement negotiated terms. IT kept the systems connected. When something changed, the company assembled the picture from ERP systems, supplier portals, spreadsheets, market reports, emails, and meetings. It was slow, but understandable. Then AI entered the workflow. An assistant summarized supplier contracts. A model flagged demand anomalies. A workflow tool routed purchase approvals. A developer used AI in a coding assistant to modernize an internal logistics application. A supply chain team tested an agent that monitored shipment updates, inventory levels, supplier risk, and port delays. This is usually how enterprise AI arrives, not as one giant transformation, but as useful pieces that start to connect. The work gets faster. The recommendations look better. The enterprise starts to feel more responsive. But productivity rarely announces the dependencies it creates. That is the issue. If you are an architect, technology leader, risk leader, or anyone evaluating enterprise AI platforms, this is the question I would put on the whiteboard before standardizing too quickly. What is this making us dependent on? Not just technically, operationally, financially, architecturally, institutionally, because the outside world will shift. A new tariff changes the cost profile of a key material. A supplier becomes exposed to sanctions risk. A port delay pushes a shipment outside the production window. A regional data rule affects how operational information can move across borders. A cloud service changes pricing. A software provider changes the terms under which a model, agent, or developer tool can be used. Nothing has failed in the traditional sense. The systems are online. The workflows are running. The dashboards still look fine. But the leadership team now has a different question. Not just, can the AI help, but what has the enterprise become dependent on? That is the question this video is about. My name is Vlad Stoyanovsky, and this is the Sovereign AI Enterprise. I look at how AI, agents, governance, infrastructure, and geopolitics are changing the way institutions operate. In this video, I want to look at a new kind of AI lock-in. Not just where technology runs, but where work starts to happen. In a previous article and video on explainable AI agent decisions, I asked whether enterprises can stand behind AI-enabled outcomes once agents touch real workflows. This is the question that comes before that. By the time an AI-enabled decision is hard to explain, the deeper problem may have started earlier. The enterprise may have built dependencies into the tools, the data flows, and infrastructure that shaped the outcome. In the cloud era, lock-in often meant infrastructure concentration, migration cost, or dependence on a particular platform service. But in the AI era, lock-in moves closer to the operating core. It shapes where employees ask questions, where developers write code, where agents take action, where data flows, where inference happens, how policies are enforced, and how costs scale. In other words, AI lock-in is not only about where technology runs. It is about where work starts to happen. Vendor dependency shows up as limited choice when a model, platform, infrastructure provider, data pipeline, or developer tool becomes too embedded to replace quickly. In a stable world, these sound like architecture questions. In a fragmented world, they become balance of power questions. This is why the AI stack matters. It is no longer just a technical diagram. It is the set of layers through which the enterprise senses change, builds software, coordinates work, governs policy, pays for consumption, and keeps operating under pressure. If those layers are flexible, governed, and portable, AI can increase maneuverability. If they are not, AI can create a new form of dependence. That is the power story under enterprise AI. The quiet transfer of control into the systems work now depends on. This is why the sovereignty conversation often gets too narrow. A leader hears sovereign AI and thinks about location, where data is stored, where inference happens, and which laws apply. Those questions matter, but data residency only tells you where information sits. It does not tell you who controls the systems that use it. The data may be resident, while the workflow, agent platform, data pipeline, infrastructure automation, or cost model is still locked into an operating model the enterprise cannot easily change. That is why dependence is not automatically the problem. Unexamined dependence is. Enterprises will continue to depend on vendors, platforms, cloud services, models, and partners. They should. No large enterprise is going to build every model, tool, data layer, workflow system, and infrastructure service itself. The real question is whether those dependencies are visible, governed, and replaceable where it matters. So let's make this practical. Vendor lock-in used to be easier to see. A company chose a platform. Applications were built on it. Data accumulated. Integrations multiplied. Migration became expensive. That familiar version of lock-in still exists, but AI changes the depth of the problem. Now, lock-in does not only happen when an application is hard to move or a workload is expensive to migrate. It happens when the way people work begins to form around the system. An employee stops searching through systems and starts asking one AI assistant. A developer stops reading documentation and starts building through one coding agent. A procurement team starts relying on one agentic workflow to identify supplier risk. A finance team starts consuming AI-generated forecasts. A supply chain team starts trusting a system to recommend reroutes before weekly operation meetings even start. At that point, the tool is no longer just a tool, it is a part of the operating model. That is why AI lock-in is more consequential than traditional software lock-in. It can shape what employees see, what developers build, what agents are allowed to do, what data is treated as current, what workflows are triggered, and what costs accumulate out of sight. That is the new lock-in problem. It is not only technical migration, it is workflow migration, developer migration, data flow migration, policy migration, habit migration. So how should leaders test for new lock-in? I would not start with the vendor contract. I would start with the work. First, the interface. Where are employees starting to ask questions? If one AI assistant becomes the default front door to policy, client history, sales guidance, HR answers, supplier updates, or operational data, can users move to another interface without losing how work gets done? Second, the agent layer. Where are agents coordinating tasks, calling tools, triggering workflows, or recommending actions? Can those agents be replaced, regoverned, or moved without rebuilding the entire process around them? Third, the data flow. What signals do the agents treat as current? Can real-time data move across systems, regions, and tools without breaking the operating process? Fourth, the developer layer. Where are software teams writing, testing, documenting, and modernizing code with AI? Can engineering change tools without losing velocity, standards, or control? Fifth, the economic model. Can finance see AI consumption before it becomes sprawl? Not just subscription cost, inference, retrieval, tool calls, data movement, automation, infrastructure usage. Sixth, the infrastructure layer. Can workloads move when risk, cost, latency, policy, or geopolitics changes? That is the practical test. Not can we leave a vendor, but can we still change direction after AI has become part of how work gets done? This pattern is not limited to manufacturing. A public agency can embed dependency into a citizen service workflow. A bank can constrain its AI strategy if it cannot change models of move workloads across regions. An energy operator can become faster without becoming more resilient. The industry changes, the test does not. Can the organization still change direction? So what does the architecture need to do when lock-in moves closer to the work? It needs to preserve the ability to move, which is why hybrid cloud matters in the AI conversation. And not just as a compromise between public cloud and private infrastructure. The manufacturer does not need one perfect place to run everything. They need the ability to place workloads where business, risk, cost, latency, and regulatory conditions require. A supplier risk agent may need real-time operational data close to logistics systems. A developer tool may need access to approved internal code repositories. A planning workflow may need to run differently across regions. A sensitive workload may need tighter control over where data is processed and who administers the environment. The point is maneuverability, and a hybrid architecture gives the enterprise more places to run AI. But more places alone are not enough. More platforms without consistent policy create fragmentation. More automation without governance creates exposure. More AI usage without cost visibility creates financial sprawl. More data movement without real-time control creates stale, duplicated, or risky signals. The architecture has to preserve choice without losing discipline. That is the balance. This is why IBM's hybrid cloud posture becomes strategically relevant. The infrastructure side of enterprise AI is not just about where workloads run. It is whether they can be moved, secured, automated, funded, and governed as conditions change. Red Hat anchors the open hybrid foundation. HashiCorp supports automation, secrets, and policy-driven operations. Apptio brings financial control. Confluent provides real-time data fabric. watsonx Orchestrate and IBM Bob sit closer to the work layer, business workflows, and developer productivity. The point is that the enterprise needs an architecture that keeps these layers governable, replaceable, and economically viable. The older argument for hybrid cloud was about workload placement. The AI era argument is about control. So here's the practical recommendation. Before standardizing on an AI platform, map the dependencies it creates. Not just technical dependencies, work dependencies, data dependencies, developer dependencies, cost dependencies, infrastructure dependencies. Then decide which ones are acceptable, which ones need guardrails, and which ones require architectural optionality. And then preserve 4 capabilities: move, govern, replace, measure. Move workloads when conditions change. Govern data access, policy, and agent behavior. Replace models, tools, or agents where the business needs optionality. Measure consumption before it becomes invisible. That is the operating discipline enterprises need before AI gets too deeply embedded to unwind. So here's the question I would leave you with. Is the enterprise building AI capability while also preserving AI maneuverability? That is the point. The future will not belong only to organizations that deploy the most AI. It will belong to organizations that can depend on AI without surrendering control over the systems they now depend on. That is the new balance of power inside the AI stack.
The data flows, a constant stream, shaping futures, chasing every dream. Complex patterns and sights unseen, a new era, sharp and keen. The world is changing, can you feel the pulse? A deeper vision beyond every impulse. Enterprise, geopolitics, AI.